Okay. So, as we discussed the other day, what we wanted to show today is actually a practical example of a VO2Max test, and to see what happens. So, we've got our guinea pig for the day, Brent Aquino, who's a former national team cyclist, back when he was younger. And we have Rob Root from the Canadian Sports Centre Ontario, who's going to be running all the equipment for us today. So what we'll do is we'll run Brent through an incremental cycling test from a really low intensity to a really high intensity. I do need one person to volunteer to stand back here and hold the speedometer next to the sensor and tell Brent how hard he's going.
I'll work with that.
Great, thanks. And he's going to start at 25k an hour, and you just basically got to give him a little heads up as to how hard he's going. It only really works if it's in around that height. So.
And who's Brent?
That's Brent. Okay. So that's Brent. If you look at all the equipment that he's got on his face,
You're going 28.
Brent, if you just look forwards a little bit, you actually can see there's a whole bunch of different things here that we're going to evaluate. This is a
Going 31.
flow meter, so slow down a bit, that measures ventilation. We have a gas port that senses O2 and CO2, so we can measure his VO2 and his VCO2. He has a heart rate monitor on, which connects to this little unit back here, so that's collecting his heart rate data. All of that's going into this little pack on his back, which is our gas analyzer, O2, CO2.
28.
You may have seen big boxes that they've used previously. We've got some great new technology that basically fits into a little tiny piece of equipment here. Even more really cool is he works up to 1 kilometer away.
28.
So we can send him out and he could ride around King's College Circle. We could sit in here and look at his data, but it's better to see him suffering in person. So we'll leave him here today. And what we're going to do is just have him run through a whole range of responses and check out a bunch of different things that happen up here. So you can see his VO2 per kilogram up top. He's around 20 to 23 right now.
30.
Hopefully you can see how high he can get up to. Think about a Lance Armstrong type. He's probably going to eventually get up to 80. We'll see how close Brent gets.
29.
Ventilation in liters per minute. Respiratory exchange ratio, that's as soon as he gets above 1, you can tell he's starting to produce a lot of lactic acid. His VO2, his heart rate, percent heart rate max, and some graphs. So I'll just talk through all of this. We also need someone to time for us. He's going to do 2-minute stages. So if someone has a watch and can call out 2-minute stages for us, that would be awesome. Great. So we'll start.
Greg, you want to do about 25?
Yeah.
Okay, you're 30 right now. Slow down. Slow down.
Easy, easy.
Yes.
There we go. All right, so
that's where you want to
start now. Now that Brent's down to his speed, we'll start the test, and we'll just talk you guys through everything as we go. So he's starting out at 25k an hour for 2 minutes.
Yep. Keep it there. That's it.
And we'll just take note of things. You can see all the data popping up here on the chart. VO2, VCO2 down here. Ventilation and heart rate, and then some of the key numbers over here, which I'll discuss. So right now, it's really easy for him. Extremely comfortable, you hope. And then we're just watching. So like 53% of his max heart rate right now. Pretty slack.
Let's slow down a little bit.
His VCO2, which tells us, if you want to really tell how difficult it's being, you can kind of compare the VO2 and VCO2 numbers. So VO2 is the volume of oxygen that he's taking in, and VCO2 is the amount of carbon dioxide that his body's producing.
Slow down.
As soon as his VCO2 exceeds his VO2, then you know that it's starting to become extremely difficult. So you can see right now here, he's at 1,700 mils, 1,800 mils of O2 and 1,300 mils of VCO2. So still very, very, very aerobically dominated at this point in time. Really comfortable, really easy for him. Let's see if there's anything else we can highlight. Heart rate's about 105.
We'll slow down a little bit.
Really, really comfortable. Is that about 115 or?
25.7.
Yeah, he's at 129.
So another thing we can do to evaluate his stress level. So intermittently, I'm going to draw a lactate sample from his finger.
Go down a little bit, right? A little bit more. That's it. Hold it there. That's right. That's 25.
Every 30 seconds. Okay.
Right, that's 2 minutes.
Almost all every 30 seconds.
Can you call it every 30 seconds about?
30 seconds.
Yeah.
Let's slow down.
So I'm just swabbing off his finger, cleaning it, so try not to infect him. We have these little one-use lancets that basically stab
That's it.
a little tiny hole, pops out, and grab about
You want that 30?
just speed at 30.
30 seconds.
We pull out about 2 drops of blood into this, and a minute later it'll tell us that his lactate is. And we just give him a little thing here to keep from bleeding all over the floor. It's always good. And then we'll be able to tell how stressful it is for his muscles. It takes about a minute to do. And the key cool thing here is just how miniaturized everything is these days. Like this used to be a box on the table. 30 seconds. Just yell at him. Don't worry about interrupting him. Every 5, okay, yeah. So 25, 30, 35. Okay. So things are climbing a tiny bit here. See his heart rate's up to 110, VO2 is up around 27. VO2 is starting to climb.
30 seconds.
And still pretty comfortable aerobically. His lactate levels, a lactic acid level of 3.
Hold there. That's
So that 2 is resting, 3 is just barely above resting, 20 is enough to kill a small child.
Speed up a
Okay,
little bit,
so
right?
like if he gets up around above 15,
That's it.
going to be suffering. Yeah.
Milliliters per minute per kilogram?
Milliliters. This is millimoles per liter. Of blood. So I'll put this away over there, and when he's going a little bit harder, we'll test
30 seconds.
lactate again.
Up to 35.
Okay. You can speed up now.
So this is his
34. Keep speeding up a little bit. 34.7. That's good.
So this is his 3rd stage.
Speed up a little bit more. For me.
And he's just going through increments in terms of time. So we have a little sensor on his back wheel that tells us
30 seconds.
how fast he's going. He's at 35k an hour right now. The average speed for the Tour de France over 3 weeks and 3,000 kilometers is around 40k an hour. So on the next stage, we'll see how stressful it would be to imagine riding at that intensity for 5 or 6 hours a day every day for 3 weeks. So it's still a little bit less than that. See the R starting to climb here, ventilation starting to climb as well.
30 seconds.
Increase a little bit.
Heart rate's up about another 10 beats.
You're at 33. You want to bring it up to 35? That's it, 35.
So that's
Should I move over there or something?
Yeah, sure.
That's great, Fred.
See here, VO2 and VCO2 are starting to climb up. So that's neat. We're also seeing the same thing for ventilation in the red, and the heart rate is blue, so that's also starting to climb up here. Heart rate on this axis, ventilation on that axis, VO2 and VCO2. I'll print all of this stuff off for you guys to be able to see later on.
Take 30 seconds in, 1 minute in, 1:30 in, and then 2 minutes.
There's another 30 seconds. I'm going to start by now.
So that's next stage up.
Okay. So I'm going to 40.
Yeah, up to 40 now.
Okay. Take it up to 48 and Brett. You're at 37. Keep going up. 38.
So now we're up to 40k an hour.
Keep going. 39. Keep going. There you go. That's 40.
Heart rate's climbing up now, 130. His max is probably around 170 to 180. So he probably has a little bit more to go, but he's around, he said 63% of his max now. See how his VO2 is climbing as well, up to 3,100 mils, 37 per kilogram. We'll talk about that a little later. Ventilation continuing to go up. The respiratory exchange ratio between VO2 and VCO2 also up about 0.8 now. So I'll probably grab one more lactate on this one just to see how that's doing.
Slow down a little bit, right? There you go, that's it.
How's the sound for you?
We're going to go 45 minutes. Go a little faster there, Brent. At 39. Now you're 40 again. Perfect.
And now we'll be able to see if he's above his threshold. Threshold is typically around 4 millimoles. What's that?
Speed up. Nice, you're 42. 44. 44.8. Go a little bit faster.
Still pretty incredible. He's riding 40 to 45k an hour at 140 heart rate. Right? Not to, Brett trains a ton. And he's in fairly great shape. So it's still pretty incredible that we're still going, Tour de France speeds right now at a comfortable, still a relatively comfortable level. We'll see how comfortable in a second. But starting to climb still, everything's still going up. Over 100 meters a minute breathing right now, pretty amazing. And shockingly enough, what's actually happening on his lactate is he's getting warmed up. So his lactate dropped. It's now only at 2.1. So what's happening there is all the blood vessels in his entire body are open. All the blood is circulating perfectly throughout his entire body. He's breathing like crazy and blowing off all of his CO2. So there's a point where your body is actually functioning perfectly for aerobic conditioning. And that's it. So we don't always see these incremental things. At some point, the body gets super efficient in everything, and that's what we just saw there.
That's good.
Now, it's for sure going to start going up. So we'll do another one near the end when he's really suffering and see how high he can get it.
And 30. 31 seconds.
Up to 76% of his max heart rate. Ventilation continuing to go up. VO2 continuing to go up. Respiratory exchange ratio getting close to 0.9. Right? So remember, we're looking at 1 for that lactate threshold, the really extraordinarily challenging zone.
Take it to 50, right?
Good job. Now we're at 50k an hour. So pretty amazing stuff here. Like, could get a ticket. Okay. Everything continuing to move properly, going along. He's in the highest gear that he can possibly be in on his bike, the hardest possible gear. Pedaling really comfortably, and things again continuing to go. These numbers are continuing to climb. Amazing values, like 55 VO2 in terms of relative VO2 is an extremely well-conditioned person. And he's still at 80%. And this is someone who's 44 years old, right? It's not easy to stay that fit.
That's perfect. That's what we want to
In
get.
your life. So it's pretty amazing stuff. Continuing to go up, the body's continuing to suck oxygen out of the air. That's why its VO2 is increasing. Continuing to try to absorb as much oxygen as possible. Breathing at 150 liters per minute now, moving air in and out of his lungs at 150 liters per minute. Doesn't even still look that uncomfortable.
49.
Producing tons of CO2 anaerobically now, so he's breathing to get rid of that as well. The heart is pounding. 165, 166. Remember, his max is around 170, 180. So we've probably only got another couple stages to go here. So you guys watch all of this stuff, and I'm going to focus on this and make sure that... Good job, Eddie. Good job. Scale of 1 to 10. How are we doing? 6? Good. Just clean up the blood.
Yeah.
Great job, buddy. Great job.
2, 1. Take that to 50. 55.
VO2, around 65 to 70.
55.
That's like, remember, 90 is like Lance Armstrong, all right? So pretty incredible stuff. Ventilation, 177 liters per minute. In your textbooks, they'll say that that is almost impossible. Okay, so that's pretty awesome stuff.
53.
Respiratory exchange ratio, 0.94. So really creeping towards that point where lactate is going to absolutely go through the roof. Great job, buddy. Great job. Great job.
Awesome. You're at 54. 54.4. That's good. Where do you want to keep it, Frank?
Good job, dude. Good job. Great job. Great work. Great work.
54.8.
Okay, 55K an hour now. Pretty awesome stuff. Good job, buddy. Good job. Great work. Great work. See on the top graph here, or the bottom graph, ECO2 is now higher than VO2. All right. So we've now passed that anaerobic threshold, and we've got really amazing work. Probably need some encouragement at this point to keep himself going here and see what we can get out of it.
Fred.
Don't be afraid to cheer. Yeah. Awesome. Good job, buddy. Good job. See if we can get 2 minutes at 60K an hour.
You do it.
How much time left at this stage?
Come on, Frank. 10 more seconds.
We've just got minutes for it.
20 more seconds. You can speed up a little bit more, Brett.
Good job, buddy. So we're going to try for 2 minutes at 60K an hour and see what happens.
30.
Great job, Frank. Great job.
See if you can speed up more, Brett. You're at 53. 52.
Okay, buddy. 1 minute to go. You're doing great. You're doing great. You're doing great.
Awesome. 52. Speed up more. 10.
1 more minute. Okay, 1 minute. Everything you got. No, don't have to worry about anything. If you die, you die. No big deal, okay? Go, 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 go. Come on. Hammer, 1 minute. As hard as you can go. Not Great job, great job, good job, good job, good job. Hammer, buddy, hammer. Doing great, you're doing great. Hard as you can possibly go. Great job, great job, great job, great job. All right. 20 seconds? All right, 20 seconds. Nice and easy.
Really nice.
Great work. Excellent. That number there was a little bit wacky at the end. Clearly didn't get to 260 liters per minute. That was neat by his nose. But I think he probably plateaued at around 180, 190 liters per minute. Pretty incredible stuff. Brent, great job, man. Great job. Did anyone catch what the max VO2 was on that? 71? 70 something? So, like, ridiculously incredible. Now, of course, we want to find out what that blood lactate number was. So, we'll just take a quick sample. Good job, man. Okay, sorry. Easy stuff. You got one? So, again, things to note on that one that are really interesting for us is just how the oxygen level, VO2, climbed the entire time. Again, I'm seeing 71. You're not going to see that very often in your life. It's pretty amazing. VCO2 only climbed up over VO2 right at the end, so that's incredible aerobic training background, showing that it's developed an amazing ability to go really, really hard without activating his anaerobic system. Pretty awesome stuff. Ventilation climbing, when we graph it, you'll probably be able to see those 3 distinct thresholds that we talked about last time. I'm pretty sure that we saw before it started leaking a ventilation of around 180 liters per minute. So he can move massive amounts of air in and out of his lungs to create the opportunity to soak in as much oxygen as possible, expel as much CO2 as possible. And we'll see what his lactate was. 13.7 on the end. So that's a huge number if you think about it. It's 14 on an incremental bike test is Amazing. Like the highest I've ever seen is 19.7 in a 100-meter, 60-second sprint. So to get 14 on a 12-minute or longer bike test is incredible. So it's a pretty good example of some highly developed physiology that is amazing to see live. The other amazing thing about this to note today is he did the entire thing in the biggest gear, and just all he did was increase the cycle rate the entire time. A lot of people will move through different gear ratios to try to make it easier for themselves to survive longer. You're just able to start at a very easy turnover and just activate those fibers moving from slow to fast speeds. Clearly he's got an amazing type 1 muscle fiber capacity, but also did quite a bit of type 2 muscle fibers once things started turning over really fast. That's where the VO2 comes from. So pretty amazing stuff. Congratulations, Brent. Thanks again, buddy. Any questions?
The lactate is in molars?
Millimoles per liter.
Okay, great.
So the first one was around 3, dropped down to 2 when he was really well warmed up, and then climbed all the way back up to 13.7 at the very end. Brent, can you describe sort of what that felt like or what's going through your mind?
Ooh. Well, the first part, like Greg was saying, it's once you get warmed up, you find that rhythm in the legs. Your breathing becomes normal. You're not too stressed. The key is when you pick up from 30 to 35 or 35 to 40k an hour, the key is not to just try to jump up too quickly, because then that discomfort zone will go up too quickly and the lactate levels will climb a little too high. But as I gradually went through it, I can feel the burn in the legs. I can feel the breathing. Granted it's a mask, so there is a little bit of resistance in there, but overall it's just mentally just trying to keep myself breathing in and out at the same rate, in and out. Trying to breathe all the way down into my diaphragm versus just the top of my lungs. And then increase again and just try to concentrate, because then I can really start to feel that lactate really building in the legs, especially in the quads. And then the breathing starting to increase and having difficulty when I went to 50 to 55 inhaling. It's the time of the year for me, so my fitness level is not quite where it is in June and July, but my inhaling I suffered on. I was having a hard time breathing in. My breathing out wasn't too bad, but I know with more fitness, and I think more than anything, that's why I started to break, because I couldn't hold the speed, because I couldn't inhale enough oxygen to allow my muscles to work, and I can only go as much as I can go. So,
Also part of the mask itself is putting CO2 back into your lungs, right?
A little bit.
Yeah, it could be too. I know, like we were already talking about it, when I race at a fairly high level still. And when I ride with some of the 28, 30-year-olds who are pros, I get within 10 beats of my max heart rate, up around 173, 174 for 90 minutes. But it's easier because you got air coming in, so you're getting it in as you're pedaling forward. So that does help. But there is a point too, when you are pedaling at that speed, sometimes you feel like you're not getting any air in, and you're right at that max. Be interesting to see what that number is, because it's fairly high. But once you recover in the fitness, then it becomes easier. But for me right now, it's the inhaling I felt difficult to do to get in enough air.
And you're breathing in through your nose.
My mouth.
Okay. So I'm sorry, do you do any inhale or exhale through your nose, or it's all through your mouth?
I do it all through my mouth. Only when I'm riding easy. But when I'm breathing hard, I always try to exhale forcefully. Greg, probably about, I don't know, how many years ago? 8, 9 years ago, the power lung? He gave me a power lung. Have you ever seen power lung?
No.
It's a
Go to
device.
powerlung.com, check it out. It's a little blue tube that has springs in it that's like weight training for your lungs. You can actually generate huge pressures on inhale to break the seal and get air in. And the same thing, huge pressures to generate on the exhales. You were training on that for a little while.
That more than anything is a psychological test, because you want to get that air in, but it really forces you to suck it in and go deep into your diaphragm and then blow it out. And when I do that prior to, because I'm a time trial guy, So I do that prior to my time trialing. It just opens everything up. So when you're doing it, it'd be like pedaling like this, what I was doing now, breathing through a straw. And then once I open my lungs and capillaries and that, then it's like the floodgates are open and you can just take in as much oxygen as you can. But that power lung really helps, and that develops that breathing. I figure, when you figure about 3 or 4%, it can help me more in my breathing over an aerobic exercise like cycling. That's huge. In the long run in racing or in cycling, that is big.
So our class on Monday is all about respiratory limitations to performance, and so we'll talk about respiratory muscle training on Monday. Any other questions for anyone about what you just saw? So the key things to focus in there, when you look at the graphs, VO2 increasing as an index of aerobic metabolism, VCO2 increasing as an index of anaerobic metabolism, the threshold where VO2 goes over VCO2 goes over VO2, sorry, it's your RER. And also watching that ventilation curve. So you can see the real thresholds in somebody's physiology as you go from a low intensity to a high intensity. And that's all in that article that I posted for you, the aerobic testing session when we talked about VO2Max. All right, guys? Cool, so I just wanted to give you an opportunity to actually see what it looks like when you truly take somebody through and go to maximum. And what the real physiology looks like. Like, it's kind of cool if you throw these look at these graphs. You know, you can actually see what's in your textbook. You just did it. So it's kind of wild. You see right at the end there, the VCO2 climbing right up into the same zone, and then the points right here where Brent was talking about just relaxing into it. At that point right there, you can see how things climb up and then settle back in again. So I like that. It's pretty interesting stuff to see. And then the ventilation curve here being the red line, you can see how for quite a while he was able to go harder without changing his breathing pattern very much. It's pretty amazing. And all of a sudden, it starts to climb, but still not really climbing all that much. Right? It's climbing, but not out of control. Like, we're still looking at between, starting at 38, he's still only at 66, but he's gone through 2/3 of the test. Then all of a sudden, you start speeding up, and you start recruiting those type 2 muscle fibers in order to create that speed. You see things, and then right at the end, things really getting steep. So that's really where we can break apart and see the training effect on his ventilatory system, and not only the requirements of delivering oxygen to the body, but also removing CO2 and VCO2. And then heart rate as well. Like, this is the point where he was really low lactate. The heart rate is actually dropping as he gets warmed up and feeling better. Then it starts to climb. There's nothing he can do about it, which is great for us. It's fine. The other interesting thing to note about his heart rate, right here at the end, is that it plateaued. So he's going harder again with no change in his heart rate. That's his maximum heart rate. So you can actually see that he's driving more physiology, he's sprinting as hard as he possibly can, going harder for a longer period of time with no change, no climb in heart rate. That means his heart is pounding as hard as it possibly can. It cannot possibly deliver any more blood into the system. And that's when your anaerobic system really has to kick in, because you're asking more of the body without being able to supply more oxygen via cardiac output, pumping blood to the muscles. So now we know that his max heart rate today is around 178. What's the highest you've ever hit on the bike in a race?
191.
Okay, so this time of season, he's not in great shape. His max heart rate is 178. Once he's in shape and he's been racing and racing and racing, you can train your heart to increase its max heart rate. Also, it's not probably something you have not seen in your textbooks. In fact, you probably have seen the opposite, where they say your max heart rate is what it is. 220 minus your age. It's bullshit. It's 44 years old, and he just got in front of you right now 178. And he knows that in the summer season, he can get 191. That's around 220 minus 30. So it's right now it's in and around accurate, but later on, you can train himself to a higher level that takes it beyond that. So some pretty amazing graphs here, some pretty amazing data. I'll post all of this stuff for you guys to evaluate.
How would you go about increasing your maximum heart rate?
He's a specialist in this, so.
What was the question? How would you go about increasing your maximum heart rate?
Well, I do a lot of what's called fartlek riding. It's meaning I do longer intervals, 20 to 30 minute intervals, and I'll go maybe 2 minutes at a steady state heart rate, maybe around 155, 160 heart rate, and then I'll go up to 170 for 3 minutes, and I'll come back down, and then I'll go back up, and I'll go back down for about 10 or 15 minutes, then I'll come back down to 160 heart rate, and I'll go up to 170 heart rate, and I'll just go up and down like that over and over again. I'll do that every second or third day, including the racing that I do. I'm more of a criterium racing also, so criterium racing is all about interval training. You sit down and pedal, pretty much 45 to 50 kilometers an hour, and then you have to accelerate to 60, 65, and then you recover then again down to 50, and then you go like that for like 90 minutes. So the body learns to adapt at that level. I do a lot of that training up and down on the heart rate curve all the time. So my body learns to adapt to the higher levels, and then I once in a while I cheat and I do motor pacing. So I sit behind a motorcycle or a car or somebody at like 80, 90 kilometers an hour. Faster than I can ever pedal. My heart rate will balloon up as high as I can, and I'll hang on to it as long as I possibly can. But by then, my body physically is in very good shape and mentally, so I can stress myself in the upper levels. And then I'm able to come down and recover right at 4 millimoles at a much lower heart rate. So the body is now adapting and learning. And I've done crit races where, because I have my own analyzer, and so at the end of a 90-minute race, I've taken a lactate, I've been 18.4 on a lactate. My body's learned to get there by doing that kind of training. But that kind of training is not easy. I was an ex-swimmer with Greg. We swam together for 20 years, so my body's been well trained to learn to do that. So it takes time to go through the difficult times. You have to really be wanting to stress yourself and go up and come down and go up and go down. Because it's easy to do it twice and then stop. But do it 5 times, then that gets here. But the body will learn and adapt. So you just have to it's called fartlek training. It's up and down on the curve all the time, and constantly increasing it over and over and over time. It takes time to develop those skills. But yeah, my heart rate can get up. Now I'm quite pleased at how high it is right now, actually. I was quite pleased with that. So it's actually, for me in November, it's pretty good. So come February, we'll get it, pick it up all over again. But it can be trained, but it takes time. It takes a lot of time. Unfortunately, because I also coach swimming professionally, I have time to train. So it requires a lot of that. So hopefully I answered it.
You know how cardiac output adjusts first before breathing does, right? That's from the textbook. So
Cool.
I don't know how valid that is.
Yeah.
Because it's in the textbook. But can we pull that kind of information from what we just did? Because it seems like there's so many variables that are going on, it's hard to actually pinpoint the location where his breathing is now taking over, whereas his heart rate. It seems to be cycling between the two until it gets to what you're saying with type 2 being activated. And then
We maximize this graph here.
Maximize that graph. Do you want me to pull up breathing rate, or we just want to?
Then we got ventilation there too. So the point that you're talking about there is right at this high end, and what you can see is the ventilation curve and his heart rate curve in blue and his ventilation curve in red. And so your stroke volume plateaus somewhere around heart rate 130, relatively early on. So any increases in cardiac output beyond a heart rate 130 are as a result of only heart rate. So if our heart rate is 130, that means any increases in cardiac output beyond this point here are probably as a result of heart rate only. So you notice the heart rate's increasing at a certain rate, but then here it seems to really increase. That's probably because at this point stroke volume's maxed out. And so at this point now we're seeing cardiac output only as a result of heart rate. And then at some point heart rate absolutely maxes out and really starts to plateau, again because it's doing everything that it possibly can. But your ventilation curve is still increasing, and right at the end that also then plateaus. And that's when he was done, right? And those 2 points come together at the final point when he just shook his head, like there's nothing left. I asked for 20 more seconds, yeah. So it's a beautiful, you can see it all sort of flowing together, and textbooks will put it so that there's this threshold and that threshold and this. But if you look at all of these variables together, it's complicated, but you can build a reasonably good mental picture of what's happening if you watch something like that. And you can see the breathing start to increase. You can watch the heart rate start to go up. You can see the VO2 numbers start to increase, the VCO2 numbers. And you can actually see what's happening to the human body as you go through a range of physiological challenges. And so, yeah, it's not just one thing. Every person's different. Some people have little tiny hearts, and other people don't. They have big hearts, literally. Or small lungs, big lungs, and people adapt differently. And the thing that Brent said about long-term training over time is really important because we can start anywhere. Like I showed you an example today of someone who's been through 35 years of training at a very, very high level, 25 hours a week for 35 years. And you can see what that results in. It's amazing. So anyone can start anywhere and get some pretty incredible improvements here. You could have a VO2 of 30 and go out and start doing some of the little things we're talking about, just like interval training or that little bit of fartlek training, really easy, and you'll see improvements in your body. Anyone can benefit from this stuff, like we talked about last time. We described the O2 transport pathway, what happens to the heart, what happens to your lungs, your blood, your muscles, everything. So many things get better if you do this type of work. So, long-winded answer to your question about O2 or ventilation and heart rate or cardiac output. So.
Well, it's a good question then, because it promoted dialogue. So.
Yeah. Okay. It's not difficult to get me talking for a long time about physiology. Any other questions? No? Okay. So your course evaluations are here. So be gentle. Take those and pass them out and get those done, and we'll pack up. Thanks, guys. See you on Monday.
I'm going to post your video on.
Yeah.